Hello, good day to everyone. Today, let's see how a safety relay functions and how to install one correctly into an electrical circuit. Even if the emergency stop is pressed, a contact weld at its normally closed contact points can keep it in a closed position, allowing the machine to run continuously. This can create a dangerous situation, risking the life of the operator and also causing severe damage to the equipment. Safety relays can effectively isolate dangerous machines when a working contactor or relay is faulty. Today, safety relays are manufactured with easy-to-install features, such as push-in, spring-loaded terminals. Here is a 4-pole circuit breaker for a conveyor motor, which requires a safety relay to be installed in its operating circuit. Shown here is a 2-pole circuit breaker for the control power circuit and the safety relay. Then you have the emergency stop push-button switch, the master relay, and the magnetic contactor. Safety relays need 2 or more relay contactors on their output side to monitor the feedback loop. Motor start-stop push-button switches and indicator lights are provided here. For the safety relay, you need a reset push-button switch. Although optional, I have included an indicator light to show that the safety relay outputs are in the off position. If the motor stops with this blue lamp on, you must check the safety relay to see the actual fault from its LED indicator lights. Before we wire up, let's enlarge the safety relay so its terminals can be easily identified. Next, wire the motor with 3-phase lines through the 2 contactors. Coil ends A1 and A2 of the safety relay are wired with a 230-volt single-phase supply through the 2-pole switch. Let's look at the operation manual of this safety relay for a moment. The supply voltage for this particular safety relay must be between 48 and 240 volts, AC or DC. For this particular relay model, the S21 terminal must be connected to ground. Also, you should know that the input circuits, the start and reset circuit, and the feedback loop are powered by 24-volt DC voltage. Then, joining S11 and S12 together will activate input channel 1, which in turn operates the internal contactor K1. Likewise, joining S21 and S22 together will activate input channel 2, which in turn operates the internal contactor K2. Y32 is for the PLC, that is the programmable logic controller input terminal. Let's go back to the wiring work now. Connect S11 and S12 terminals through one set of NC contact points on the emergency stop switch. This is input channel 1. Then connect S21 and S22 through the other set of NC contact terminals to enable input channel 2. The reset switch needs to be wired between S12 and S34 terminals, and must also pass through the 2 NC contact points on the 2 contactors. Terminals 13-14, 23-24, and 33 and 34 are safety contacts, which can be used to operate equipment safely. Output contact points 41 and 42 are auxiliary contacts, which can be used only for display purposes. So, we take a 230-volt phase wire through terminals 13 and 14 and connect it to the A1 terminals of the 2 contactors. Connect the neutral line to the A2 terminals. Connect the control phase line to the indicator lamp through terminals 41 and 42. Connect the neutral line too. Wiring for the motor start-stop and indication lamps are not shown here, since it has been discussed previously in the emergency stop switch wiring video. The LED indicator lights on the safety relay are enlarged here to make them more visible. To see the operation of this circuit, switch on the 4-pole breaker first. The master relay now receives 3-phase power. When the control circuit breaker is on, terminals A1, 13, and 41 receive power, and the power LED is now on. At the same time, the NC auxiliary contact at point 42 releases power to the display lamp on the panel board, and shows that the output power of the safety relay is still off. If the NC contacts on the emergency stop switch are closed, input channel 1 is activated by closing the terminals S11 and S12. At the same time, input channel 2 is also activated via terminals S21 and S22. Now, you can start the safety operation by pressing the reset button, which in turn passes 24-volt DC power to terminal S34 from terminal S12. The reset LED indicator light comes on when S34 is supplied with 24 volts. This will activate internal contactors K1 and K2, allowing the normally open contacts at 1314, 2324, and 3334 to close. So, the LED indicator for the output is now on, and terminal 14 sends 230 volt control power to the motor run contactors. Before the reset button is released, the reset light goes out. This is because the start loop is now disturbed by the opening of the NC contacts on the contactors. Also, the motor starts running now, as the contactors have control power. Further, terminal 42 now has no power, so the output shutdown light is off. If you press the emergency stop button now, input channels 1 and 2 are deactivated. The LED lights for those two channels are now off. Terminal 14 no longer receives 230 volts, so both contactors cut three-phase power to the motor. Terminal 42 receives power again and lights the indicator lamp on the panel board. The fault indicating red LED will not light up here, because both input channels were turned off simultaneously. The operation can start again by first resetting the emergency stop button and then pressing the reset button. Let's see another operating condition of the emergency stop switch now. Here, you can see that the upper NC contacts have a welded condition. Input channel 1 is deactivated here because the lower NC contacts have opened correctly. So the output is turned off, and the motor comes to a safe stop without any problem. But the fault indicating red LED has now lit up, since input channel 2 did not turn off simultaneously. Also, you will see that the LED light on input channel 2 is now flashing, while the red LED fault indicator stays lit continuously. The system cannot be reset until you correct the fault on input channel 2, by replacing the faulty emergency stop switch with a good one. Also, if any contactor on the output side is faulty due to contact welding, it will not be possible to reset the safety relay. Since the reset loop is connected via the NC contact points on the output side contactors, any open NC contact in the loop will prevent resetting the safety relay. So, you need to attend to the fault, and replace the faulty contactor before resetting the safety system back to normal. I hope you now have a good understanding of how safety relays work, and also how to install one into an electrical circuit. If this video is useful, please subscribe to the channel. Thank you.